Welcome to Manifold. My guest today is Jaan Tallinn. He was a guest on the podcast a few years ago. I will put a link to that earlier interview, which I think was a really good one, in the show notes. Jaan was trained in theoretical physics. He was a founder of Skype, and I believe he might be the world's greatest AI investor. I'm going to ask him a little bit about how he feels about that. But as far as I understand, he invested in a lot very early on in a lot of the most important AI companies in the world, including, for example, DeepMind many years ago before it was acquired by Google. We are going to talk about what we both see as a kind of super acceleration toward AGI, updating on GPT-4 and recent successes with large language models. That's what we'll focus on in the conversation. Maybe at the end, if we have a little time, Jaan will tell me about his adventures in Tokyo, where I know he likes to travel. Jaan, how are you?
I'm very good. Thank you.
So let me just get this out of the way. Is it true that you're the world's greatest AI investor?
Oh, I don't think so. I do think that DeepMind and Anthropic are kind of like two notable entries in my portfolio, but I think that's about it when it comes to kind of first tier.
Okay, I thought for some reason I thought you had been. My impression was that you were very early in a lot of the most prominent AI companies, but certainly those two count for sure, Anthropic and DeepMind. So let's talk about the acceleration toward AGI, and I think we were just both saying before we started recording that rather than being decades away, we think it could be years away. How do you feel about that?
Anxious. Because one thing that is pretty much guaranteed, even if kind of AI stops now, the world will change now, because now we have human comparable minds that you can run on a USB stick.
Yes.
Which is very, very weird situation.
Yeah, I would say, just to define terms a little bit, what I think AI researchers think about as true AGI is still a couple leaps ahead of where we are now. But as somebody who is the founder of a company that builds narrow AIs for enterprise, I can already see that we can build things that will seem to the average person like an AGI with existing technology. So if models didn't get any better or only a little bit better from now on, I think we could still build something which is a very good personal assistant that gets to know you over years living in your phone and will kind of seem like an AGI to most people, even if it's not truly an AGI under the hood. Do you agree with that statement?
I think the definitions are just doing a lot of work here. I do think that you can kind of set up, as of last year, reasonable operationalizations for a Turing test that the AI would be able to pass. We're definitely kind of hitting the low end of AGI definitions. So people are now just busy moving the goalpost.
Yeah, I agree with that. So I think we passed the Turing test, and now everyone's kind of forgotten about the Turing test. I guess for me, the module that is still missing is a kind of long-term planning, extended reasoning, and goal orientation component.
Yeah, that's exactly right. I do think people quite often are kind of too hung up on volition and whatnot, but I think that is missing is long-term planning.
Yeah. So in our startup, we build kind of an attached external memory that we can kind of plug into the LLM so it doesn't hallucinate. But also as an external module, you could, I think, go a long way toward longer-term planning, longer-term thinking, and goal orientation, sort of as an external module. What I'd like to see what I think is possible to happen is, that could be incorporated in the neural net structure itself, but that may require a few more breakthroughs.
Also, in some ways it would be nice not to, because that would make the system more transparent. And also, humans, we are happy to work while kind of looking up and Googling and whatnot. So I do think it's from safety perspective, I think like more modular systems are preferable.
Yes, exactly.
Than end-to-end black boxes.
If the goal orientation and long-term planning is an external module, which is more transparent to an ordinary human programmer, that seems much safer.
Exactly.
But you do sound pretty concerned, although maybe it's because it's the end of a long day or something for you. But you do seem like so. For me, I think perhaps this isn't a good way to view it, but I'm just so excited about the pace of progress of the technology. I guess maybe I'm overlooking the long-term dangers that you're more focused on. But are you close to maybe calling for a moratorium or something in terms of further advancement?
I mean, I'm one of the co-founders of Future of Life Institute, and Future of Life Institute put out a 6 months pause letter, which admittedly did not ask for a moratorium on AI. It just asked for a moratorium on the frontier experiments.
Right.
So I do think that the frontier experiments are completely reckless.
I see. Now, being an early investor in Anthropic, do you visit their headquarters and yell at Dario and tell him to stop? How does that work?
I mean, that I don't try, because that wouldn't work. But sure, like I try to kind of insert, kind of like strategy in general when it comes to investing in AI companies. And people quite often ask me like, well, if you're afraid of AI, why do you invest in AI companies? Is to basically have a voice in a company and displace investors that do not care. At the same time, kind of the main constraint that I try to satisfy is to not accelerate those companies. So I'm never kind of like a major investor. I'm always like a small investor.
I see. Now, do you have, stepping back from prescriptive, policy suggestions for people, I'm just curious what your feeling is about how scaling is going to go in the next few years. Are we compute limited? Are we architectural idea or algorithm limited? And any thoughts on that kind of thing?
Yeah, there seems to be, again, like I'm not like completely close to the metal, so like I'm not an expert here, but from like not afar, but like from like some medium distance, there seems to be some kind of trade-off between data and compute. I mean, one kind of clear way to look at it is that like 0 in alpha 0 meant 0 data. So you basically ran like fully on synthetic data, right? So now the question is like how much compute you can convert into high quality synthetic data, mm-hmm. Which is like the jury is still out there, but I think it's fairly likely that synthetic data will kind of be valuable. I mean, one way of looking at it is that like all data is just like a result of some physical process in this universe, right? Like, I mean, the language, text on the internet, there was just like some output of a bunch of human brains, which are physical systems. So in some ways, there is like no qualitative difference between synthetic data and I don't know what just data, the human generated data. There is just the question like what kind of corners of the universe you are sampling or something. Is your data kind of orthogonal enough to cover the domains that you're interested in?
Yeah, I think that, so a few comments on this. Like, I can plausibly see how they're going to get a 10x in compute. I can plausibly see how they're going to get a 10x through clever, modifications of the architecture, different ways to do the attention heads and things like this. I think Anthropic I suspect they're making some innovations there. But many people say, well, it will be tough to get more than kind of like a 2x of natural data coming from humans. And so then this question of to what extent can you start using synthetic data, maybe synthetic data that is filtered or improved by some human review? Can I still get another 10x? It seems plausible that you can, although there's a significant work factor there.
Yeah, I think it's again, jury's out there,
Yeah.
but I think it's very plausible because again, like ultimately there is no kind of philosophical difference between natural and synthetic data. They're just all results of physical processes.
Yeah. I don't think there's a philosophical difference, but I think there could be a problem that some weird idiosyncrasies could sneak into the AI mind universe if you keep in a sense, recycle the outputs of other AIs back into the new AI.
Oh, sure. Like, I mean, synthetic data doesn't necessarily mean that it's kind of derived from natural data. You can also, I mean, like the data in alpha 0 was not derived from natural data, right? So it's like you can also, use things like code, etc., to kind of get your synthetic data.
Yeah, and I also think that the level of data, very useful data, that will be generated from AI human interactions, obviously that's going up very fast. In some of the customer support AIs that we're building, those things could have, millions of conversations relatively quickly after full deployment. And so that's a sort of qualitatively new source of data that hasn't, I think, been used that much so far in training.
Yeah, and again, like in all areas where you have some kind of like crowd level check, you can check against, like, is it like logically consistent? Does the code run?
Yeah.
Or does it satisfy some kind of external constraint? Then you can have like you have much easier time baking a signal into your synthetic data.
Yeah. Another area that I think we probably will see some progress on, but I'm not aware of there being progress yet, is some better way to integrate sort of video and language all together in a natural way, and use that to train, some kind of big transformer that's acting across all of those spaces simultaneously. I mean, maybe some of that is already in Sora and things that we've seen, but I think that could go further. I think there's room for quite a lot of innovation in that direction.
Yeah, I mean, Sora was definitely surprising to me. So like, and I have like very little idea how it actually works under the hood.
Yeah, my suspicion is that just as the language models are dealing with conceptual primitives that it extracts from looking at lots of human language, there are visual primitives as well. In fact, in a way, the fact that I can describe what I'm seeing to you means that our brains actually, map the visual primitives back into the language primitives. And so somehow I think what they've done is actually have the model acting directly on these visual primitives and then string them together in a way that looks sort of consistent with physics and stuff like that. I mean, those are just words, but I have a feeling that's what's actually going on.
Yeah. Okay.
Yeah.
Yeah, I don't know.
So what do you think is going to be the next sign of danger of some kind of, real threatening development that we should be looking for?
I mean, I think two things that kind of come to mind. One is just like there's more and more efforts in developing evals. There's also a lot of criticisms of evals that they are just like a tool for safety washing and whatnot. On the other hand, like I think it's still better to have those than not. So some strange evals starting to trigger. System just able to make copies of itself, things like that. And the other sign is just like general like sort of warning shots. I think the most plausible warning shot that we might get is AI hacking its way out from the data centers that it's being trained. I think one underappreciated area is like what happens during pre-training. And unless the data is like very carefully sanitized, which I'm pretty sure it's not, it's constantly being provoked. So there are definitely like token sequences in the data that provoke this AI to kind of spin up an agent that tries to hack systems and tries to kind of make copies itself and whatnot. So it's and in some ways, as my friend Andrew Critch says, that our cyber infrastructure is much softer than our physical infrastructure. So like there is like this hope that once we get like a breakout in cyber infrastructure, it will not spill out into physical infrastructure, but that's just hope.
To me, the idea that the idea that a human could use an AI to develop some very powerful hacking tools, that seems pretty imminent. The idea that the AI, quote, understands that it's locked in a data center and would like to see more copies of itself in other data centers, that motive or goal, that doesn't seem like something that we're close to creating within the AIs. Do you agree with that?
I mean, it's okay. Like, I think like two observations there. Like one, first of all, it's kind of capabilities question. I can already kind of like prompt some AI, ideally some base model to do just that. And it's just not capable of hacking out of the data center that is like being instantiated in. So it's a capabilities question. And the other is like a motive question. I do think it's really important to kind of differentiate between the LLM as a sort of label for like a configuration of graphics cards and electrons running in them, and like the agents that it instantiates while it's being prompted to do so.
I see.
So like if you ask a ChatGPT to produce a dialogue between two agents, it will try to be faithful to what these agents are thinking while producing this dialogue. So like from this you can get great kind of like agents that are motivated to accomplish real goals, not on the LLM level, but on the simulation level that the LLM is performing.
So let's suppose I have a language model or some general AI that has been given access to lots of APIs. So in our work, we're getting to that point now where some of the companies that use our AIs, the AI is able to send a shipping label to somebody or make a refund, or we're not at a point yet, although it's contemplated, book airline reservation, things like this. So let's imagine that now this thing has pretty powerful APIs. So in particular, it could copy a file or something. It could open a TCP/IP connection and transmit a bunch of data somewhere else, and maybe even hack the other system on the other side and get it to execute the file that it sends. Then at that point, I can see somebody getting the AI to do those things, but the persistent motivation for that AI or even the copied AI in the other place to want to continue that activity. How do you see that materializing?
Yeah, I mean, I'm totally speculating here. I'm just observing that AIs currently are being, like, most of the compute is spent. Actually, I think most of the compute is spent on okay, let's phrase it differently. There are kind of two frontiers when it comes to AI on this planet. One is like the implementation frontier, like where people are just like figuring out where to plug AIs as they are doing inference. And I think this is definitely an area that we should keep an eye on. The kind of silver lining is that like this is like a technological frontier. Like we are just like looking at the uses of technology. So there are like bunch of the experience that we have regulating and constraining new technology kind of applies. And then there's the other frontier, which is like what happens during pre-training? What happens during those months-long periods during which like megawatts of electricity and terabytes of data are being poured into this like black box, and that just like hums there in the cellar or whatever the data center is. And this is like the other frontier. Now the question is like, what current guarantees do we have about this frontier? Because the knowledge about these data centers, the knowledge about these like insecure systems that are being trained on, it's there in the data. I used in the AI and in the data. One example that I keep giving is that I used GPT-4 to help me to configure my own firewall. It just knows this thing. It just doesn't connect the dots yet, but like during the pre-training, it has the information that it needs to break out of the data center that is being pre-trained on.
Yeah.
Again, by it I mean like potentially some agents that it is simulating, not the LLM itself.
I agree. And then, so now carrying this forward, I guess it could, if it copies itself, that sub agent copies the big LLM to another data center and then also prompts the new version of itself to also run it.
I think
go ahead.
This is like also possible, but I think it's kind of like inefficient. I think it would be better for this agent to do something kind of like, the way I visualize it is the kind of like it starts treating the compute substrate that is being instantiated in as its environment. And so it doesn't, if it needs the LLM, its environment to continue the existing, then yes, it needs to copy it. But there are probably like a bunch of stuff that it doesn't need. So you can just like take a few graphics cards worth of weights with it and replicate this or something. I mean, I don't know. Like this is like a pure speculation, but like, but what I'm constantly pointing out is that like we do not have guarantees that something like that is not happening. It's not possible. Although like also like another silver lining is that I think it's possible to get some guarantees when kind of like reasoning about things like loopiness, like how much state is being evolved while pre-training happens. Yeah, how many sequential steps can a state evolve, for example, and perhaps like some ideally, I'm really looking forward to some kind of guarantees from the operating system or hardware itself. For example, one idea that I've been promoting is in synthetic biology. Scientists have this approach where they make the synthetic organism dependent on some kind of chemical that doesn't appear in nature, right? We could do the same thing in AI training by having secure enclaves in the compute, like GPUs and TPUs. I don't know if TPU has a secure enclave, but anyway, those secure enclaves, they should expect some kind of signed tokens. And once this like trip stops, they should just like turn off the rest of the graphics card or TPU. So I think that's like totally implementable, and I think it's a responsible thing to do. But of course, this is just like a high-level sketch, not the actual.
Yeah, I like that idea.
Plan. So that would also give us some kind of invariant that we can reason about. But currently, it's just very low invariance.
Would you say that the amount of resources invested in interpretability of models, to make them safer, just to understand what the threats are, that level of investment is way too small compared to what's being spent to improve models?
On a first level, yes, I would say. So like obviously like everything kind of everything is dwarfed by the like hundreds of billions or like tens, if not hundreds of billions that are being thrown at making models more capable. On the other hand, like one lesson that I learned over the last decade or so is that so-called AI safety and AI alignment tends to be a double-edged sword, because like all advances in safety pretty much are immediately poured into AI capabilities. So like once you understand the AI better, you can also like save on compute or make it more capable.
Yeah, I agree 1,000,000% with what you just said, because the most insightful discussions I've seen of interpretability and such of models and is always from that was a very nice thing to say, but from researchers who are doing it to make the models better. So it seems like the people who are, I shouldn't say it this way, but the smartest and most serious people who are trying to figure out model interpretability are doing it with the goal of making the models better and better, faster and faster. And it seems like the safety people, while well motivated, aren't the ones that necessarily are having these insights. So there's definitely an imbalance there. And so if you took all the top mathematicians in the world or something, or theoretical physicists, and had them working on this problem, the endpoint might just be like 10x faster improvement of models from their results, right? So
yeah, so I think like from safety perspective, I'm now kind of more leaning towards, what kind of constraints can we kind of build into the systems, be it like hardware constraints or some kind of like provable. I mean, David Dalrymple is kind of working at the UK Advanced Research like DARPA equivalent, basically.
Oh yeah.
And his program is about he calls it like open agency architecture, where you kind of use the. I mean, I'm going to butcher the explanation, but it's basically the idea is that you, as AIs get more capable, you also use that capability to have those AIs produce proofs of what they're going to do. So you can like have like a simple proof checkers to check whether this is safe or not, what the plans are.
Yes. Now, when people ask me about, well, so what's the current situation with AI, I often tell them, number one, I've never seen a field moving forward so fast, because you have this confluence of massive financial and economic resources, massive human capital, and actual real excitement. I mean, people maybe should be more concerned the way that you are, but most young technologists and scientists are just excited about like being able to do cool things. So you have this confluence of these things, and then there's also geopolitical competition. So I've never seen stuff like this. Even the early nuclear programs, they weren't really moving that fast because it was bottlenecked by just a small number of people who understood the physics, who could really, contribute. Where here it's like a much larger set of people that can contribute. So
yeah, I think it's like similar to the nuclear field in a sense that like there's now kind of overhang of scientific results, and now it's just like engineers are implementing things and experimenting, etc. So it's AI is building digital aliens is now an engineering.
Yeah, exactly. That's how I would put it. So for somebody who is really concerned about safety, what's a plausible good outcome in the next few years in terms of policy, measures, or governments agreeing, on ways to slow this down a little bit or make it more safe? If you and I get in a time machine, we come out, it's 5 years later, and it's the best universe that you envision, what happened during those 5 years?
Yeah, so I have this webpage, jaan.info, where there's like page jaan.info/priorities. And there are like 6 priorities currently there. One is data center certifications. Basically, AI should be trained, like the frontier AI should be trained in data centers that have certifications about certain invariants, ideally things like hardware constraints and whatnot. Second is speed limits. We should bake into AIs some kind of limits when it comes to inference speeds, because potentially AIs could be like 1 million times faster than humans. Humans potentially could be just plants compared to AI. Third is liability laws, figuring out how to kind of, if something goes wrong, how do we backpropagate the liability to the place where it's easiest to fix the problem. Fourth is labeling requirements. This is the easiest one, just making sure that AI outputs cannot be confused with human outputs. Fifth is veto committees. This is like a governance and more complicated idea. And the sixth one is global off switches. Basically, something that I discussed earlier about this like drip of secure tokens or some other mechanism that allows us to, that still yields us some kind of control over a situation if things seem to be going really wrong.
Got it. Yeah, those are all good ideas. If I come back for a moment to the nuclear arms race, which I have maybe some people would say an unhealthy fascination with since I was a kid. I grew up in the Cold War, so obviously, and so did you. So,
same here.
So if you're a physics guy and you grew up in the Cold War, it's like there's an unlimited, rabbit hole you can go down to think about this. Now, it seemed like really nothing stopped. So you throw in this component of geopolitical, not just economic competition, but real hard power geopolitical competition. And so there you just had governments expending, what it took and taking some of their best minds, and actually in some cases, like with Landau, forcing them to work on, the bombs. And there was really no curtailment of what they were trying to do. I mean, we were talking about putting bombs in space and orbiting the Earth and talking about, cobalt bombs that could destroy all life on Earth. And so didn't seem like anything really stopped it until just the countries decided it was in their own interest to negotiate a slowdown in the arms race. And during the process of all this development, they were doing things which, harmed a lot of people, like killed a bunch of, Pacific Islanders with radiation, even killed Navy people, like when they were testing to see whether what the bomb would do to a Navy fleet. They definitely, took huge risks. And so by comparison with the AI threat, where it's a little bit abstract, right? It's someone very thoughtful like you saying like, oh yeah, but just keep extrapolating and we get into this huge problem. But that's much less visceral for a politician or average person to understand than like, oh yeah, when we do nuclear tests, we kill some people, or, we make this huge place unlivable, in Kazakhstan or something for decades. Like even that kind of thing didn't stop breakneck development on the nuclear side. So what's a plausible way to get this done on the AI side?
I don't think I have like a very easy answers. I do think that the trend is positive. Like if you look at like the world pre ChatGPT 4 or just ChatGPT and post, I think it's much easier to find politicians who understand the problem and are trying to do something about it. There are like legislative initiatives here and there in US executive order. And also like China has put out some legislation, I understand. And there are more going to be international efforts. And myself, I'm part of this UN AI high-level advisory body. We'll see what happens there, but I think like again, this exists because of ChatGPT 4. So like a lot of changes, a lot of positive changes are also downstream of ChatGPT 4. So I continue to expect something like that. So like we will, like new AI releases will eat into our runway as a civilization, but will also give us like more resolve to do something about it.
Yeah, I agree with you. I mean, every advance concretizes the threat even to people who are not experts, right? Maybe in the next...
Again, you can now talk, you can take a computer and talk to it. Like how like in what way this is not science fiction?
Well, I keep having to admit that this is the world I dreamt of as a young person. So,
sure. I mean, if I put on my engineering hat, it's also cool. But like, I also need to kind of. I also have my physicist hat, and think that in the end, the game is what kind of configurations of atoms are reachable from here, and do they contain human-shaped objects?
It occurs to me, so a conversation that I've often had with other science fiction fans is that people have said that, Frank Herbert was by far in some ways the most insightful, because setting a drama 10,000, 30,000 years in the future where humans have clearly developed a lot of technology, but humans are still the main drivers of the action, has to have an explanation. And in his universe, the explanation is this Butlerian jihad, where humans had a close brush with AI takeover, and then they passed these really draconian laws. And the statement is, "Thou shalt not make a machine in the image of the human mind under penalty of death," right? In this Dune universe. I think if we hired who's the guy? Demi Villeneuve, who's the guy who directed Dune? Demi Villeneuve? Anyway, if we hired him to make a little short feature about the Butlerian jihad, like the close brush humans had with the AI takeover, and then how they then enacted all these restrictions on it. Maybe that would be a good way for average people to understand, what's going on here.
Yeah. Many thoughts about it. First of all, like I think that there are already many people thinking about like how to kind of visualize the threat. So I expect several movie projects coming out in the next few years. Second is that I think like sort of ordinary people don't even need much convincing. At least some of the polls show that they seem to be much more on board of this. Like, wait a minute, why are you doing this? I think the most resistant people to kind of reasoning about the AI are, I don't know, some kind of like, I don't know what is the exact common denominator, but like basically a subclass of intellectuals who just like want to say smart things and not saying crazy sounding things. This is like one heuristic that they follow when they want to sound smart.
Yeah, I agree with you. It's so funny because as I was waxing eloquent about Dune and the Butlerian jihad, I realized like a common sense approach to this whole thing, which I hear, like you might hear on Reddit, is just somebody referencing Skynet in the first Terminator movie, which is obviously quite old, but they're not wrong. Like, why do I have to make a Dune movie when I could just reference like Skynet? Right? So
the AI safety community was so frustrated that like everything we said or did was like kind of accompanied with a picture of Terminator. But the movie is not actually bad.
It's not actually. It's not. So, and I think
given the constraints that you always have to make like an interesting movie, whereas like realistic AI disaster will not be interesting to humans. With that constraint, I think the Terminator movie, as well as many other movies, have been like really good.
Yeah. So now that I think about it, it's like, well, this is already baked into the culture. It's just, and plenty of average people actually get the point. Like, do we really want to?
At least in the West, the situation is a bit different in the East.
Yeah, maybe you could talk about that. When you, I know you, for example, you like to visit Japan and Tokyo. Like, do you have conversations there about AI risk?
Yeah, I mean, first of all, like the Center for Future of Intelligence at Cambridge, they a few years ago they did this like comparative study about like AI narratives in different cultures, and I think their summary really was that in the West you get like this dystopian Terminator scenarios like that dominate the AI discourse or AI fiction universe, whereas in China and Japan, the typical AI narrative is about robots becoming conscious, and once they become conscious, they are just like us, except they're not us. So you have like this like narrative problems about like ethics and like how do you relate to robots, etc., which is just super unrealistic. But like it is kind of positive narrative, but it just doesn't make sense.
When I was a very young kid, my brother and I would get up early and run downstairs to watch a cartoon called Astro Boy. I don't know what the Japanese name of it is, but in English in America it was called Astro Boy, and it's literally a retelling of the Pinocchio myth, but the little Pinocchio character is a robot. And so it's a machine come to life, but it's a lovable, loving, wonderful little boy robot. And I think that's probably one of the most influential bits of anime that's ever been made. So I see where that comes from.
I mean, it's also kind of possible, but like who enforces the constraint that these robots are not going to develop their successors? Like
it's not. Well, again, like back to Frank Herbert, he had the insight to say, like, wait a minute, like this is going to happen technologically, and then the humans have to react to it a certain way. Otherwise, when I write the science fiction, the progenitors are all going to be giant machines and stuff, right? So,
not to mention like Werner Vinge, who just in his like zone of thoughts.
I didn't realize Vinge had died.
This problem.
Sorry, I didn't realize that. So
just like a couple of weeks ago.
Yeah.
So really unfortunate.
So, all right, I promised I wouldn't keep you too long because I know it's the end of a long day for you. So final remarks, maybe you could just say like, what are you trying to do to keep us safe from these machine aliens that we keep trying to create in our midst? And what should average people do if they want to help?
So it's a little bit like hard for me to answer currently because like I'm kind of in the midst of kind of switching my strategy from just supporting AI safety research, which I have done for more than a decade, towards kind of more direct action, which is like just like finding groups of competent people and supporting them to like either develop some new approaches like AI, kind of, what's the word? Like provable safety or some other kind of like using mathematics as constraints on AIs, or trying to advance some legislation about that kind of would apply to these frontier AIs. And then, yeah, I'm part of this UN group, which another kind of thing that is about kind of more direct action than just like supporting groups from afar, or supporting researchers from afar. And like when it comes to like ordinary people, I think it's few things. One is just like read up on things on this like Discord. This kind of AI safety concern is now. I mean, depending how you can go back to Turing, Alan Turing, but I think it really kind of picked up like a decade ago or so. You can apply kind of pressure to politicians, so they would educate themselves and be kind of more motivated to push through or see through some legislation that would kind of make things safer. And then finally, yeah, I think it's still useful to actually interact with AI, so you actually know, have some first-hand experience, like what they are about. They are like becoming less and less tool-like as they advance.
Got it. And do you continue to invest in AI companies, or do you find that not a good thing to be doing?
Yeah, I do. Although, like, I mean, in general, I've delegated away my investing to kind of dedicated full-time team, so I don't spend that much time in it. But sure, like, whenever I see an opportunity that I think would make the group safer, I try to take that opportunity.
Good. Well, Jaan, thanks a lot for your time. I want to keep this short, and I hope we can talk again sometime.